Yeah, Assalamualaikum and very good day to my panelists. My name is Muhammad Aidil Syukri Romantic number AM19002. Today I will present my final project with the title of the effect of red ginger, Alpinia purpurata and Noni fruit, Morinda Citrifolis extract as natural preservative on the homemade cake. In terms of the antimicrobial activity and phenolic composition. So the main cause of the food spoil is because of the growth of the bacteria that led from the oxidation process of the surrounding environment. The microbial activity caused the food to lose its flavor and texture. Generally, as safe GRAS of various natural substances has great potential usage in the food industry, and many research have been published in this topic. Due of the existence of bioactive chemical, many plants have been shown to have antimicrobial antioxidant properties. In this study, the phenolic compound of M.citrifolis and A.purpurata was extracted using Soxhlet extraction technique using ethanol and methanol as solvent. The purpose of this study is to determine the performance of the plant extract as food preservative in terms of the antimicrobial activity and phenolic content. The phenolic content of the plant extract was measured using Total Phenolic Content test and the antimicrobial activity was measured using this diffusion method by measuring the inhibition zone on E. coli and epidermis bacterial. After that, the extract was applied on a homemade cake to observe the performance at inhibiting fungal growth of the cake for 40 days. At the end of the study, it shows that A.purpurata has the best effect on antimicrobial activity and the highest concentration of phenolic content. The study also shows that methanol is better solvent to extract phenolic compound from the plant extract. For the background research, the problem segment of this study is the food sector is concerned about microbial food deterioration. Microbial activity caused the loss of the 25% of food produce after harvest. Chemical additive has been widely utilized to inhibit microbial growth, and the safety of these chemical additives is critically debated and doubt its effect on human health. Bacteria and spoilage microorganisms in food must be reduced or eliminated. So to overcome this problem, some solutions are with the application of plant extract as food preservative. GRAS is stand for the generally recognized as a is designation that is a chemical or substance added to food is considered safe by experts under the condition of intended use. Plant oil forensic to make more natural or green food while also extending the shelf life of the food product. Phenolic compound that found in the plant able to inhibit and prevent the growth of the spoilage and pathogenic microbe, as so done the oxidative reaction with food system. The capacity of the phenolic compound in to bind with the active site of the important enzyme and the effect the microbial and metabolism. So the objective of this study is first is to extract the phenolic compound from the red ginger, Alpinia purpurata, and Noni Morinda citrifolis using Soxhlet extraction method. Second is to characterize and compare the phenolic compound present in the red ginger, Alpinia purpurata, and Noni fruit, Morinda citrifolis, and observe their physical and chemical properties. Next is to observe and evaluate the antimicrobial activity of the synthetic preservative red ginger and also noni fruit, Morinda citrifolis, phenolic component on the homemade cake. So for the methodology, for the first step is the sample preparation. The first noni fruit and red ginger were obtained from online store. 500 of gram of this plant sample were purchased to use for this project. The fresh plant was washed using normal tap water and distilled water to remove dirt and impurity to make sure pure plant sample were able to obtain. Next, the plant sample were cut into smaller pieces. It can be easy to manage later. Using an oven, the dry plant sample is dried using oven at 70 degrees Celsius for 2 hours. After that, using a grinder, the plant sample will crush into powder. From this, around 200 grams of powder is obtained from the grinded plant sample. So the next step is the extraction process. Using the Soxhlet extraction process, 200 grams of each plant sample were placed inside a timber, placed in Soxhlet extractor using a Soxhlet apparatus inside a biosafety cabinet. Then using ethanol and methanol as solvent, 500 ml of different solvent were in distillation flask. Distillation flask were heated at 90 degrees Celsius for ethanol, 75 degrees Celsius for methanol. The extraction process will run for 8 hours. Then the extracted liquid was collected. Then using a rotary vacuum apparatus, the extract from the both sample were concentrated. For the next step, there is total phenolic content test. By using a following calculator reagent, the sample were added into test tube containing 0.5 extracted sample. Using a vortex, the mixture was mixed homogeneously with 2.5 ml of sodium carbonate were added to the mixture after 5 minutes. Then the mixture was incubated in the dark for 2 hours. The observation was determined at 765 nanometer by using UV-based spectrometer. The test was duplicated and result is average. The standard curve with the gallic acid used to quantify the result. The phenolic compound of the plant extract were measured in milligram the gallic acid equivalent GAE per gram dry weight of the plant. For the next process, there is this diffusion method. For this analysis, two types of microbes were used for the analysis of antimicrobial activity of the plant extract. E. coli as gram-negative and S. epidermis as gram-positive. 10 ml of extract was dissolved with 9 ml of distilled water. A final concentration of 100 ml mg per ml were prepared as the stock solution. Using tri-blind paper disc of 6 mm diameter, 10 micro ml each extract was placed. The paper disc will later be dried. After that, the petri dish was split into 4 sections to make sure that the disc able to identify by different by. Distilled water was used as a negative control. By loading the dish with distilled water, a positive control streptomycin disc was used and placed inside on the bacterial culture. The disc was later dried before transfer on the bacterial lawn. Then the petri dish was placed inside the incubator at 37 degrees Celsius for 24 hours. The microbial activity of each extract was observed by this diffusion in natural agar slide of E. coli and S. epidermis. The inhibition zone of the dish was evaluated by measuring the diameter of the inhibition zone. So for the next step, there is GRAS chromatography mass spectrometry analysis. Um, Elegance technology and gas chromatography were used to analyze the compound of the plant extract. The column you use is DB5 with 30 meter of weight wide with 0.25 millimeter and 0.25 micrometer film thickness of elegance technologies column were used. The oven temperature is 90 degrees Celsius held for 2 minutes and 90 to 300 degrees Celsius at 4 degrees Celsius per minute. So the last step of this methodology is the application of plant extract on cake. Noni fruit and red ginger were applied on a homemade cake using a common cake making recipe with some modification. After the cake is fully baked, the cake was cooled until it reached room temperature. Next, the cake was stored inside a Ziploc bag and installed at room temperature. So there are 4 types of extract cake that were baked for this experiment. The cake without addition of the plant extract or chemical preservatives was the first type. The 3 other cake were cake with the addition of noni fruit and red ginger extract, also benzoic acid as its positive control. Okay, for the result and discussion, for the first result of total phenolic content, the concentration of plant sample were able to determine as shown as figure below. The highest total phenolic content concentration of the plant sample is from A.purpurata using ethanol as solvent with value of 29.9 mg GAE per gram, and the lowest total phenolic content is A.purpurata using methanol solvent with value of 13.307 milligram per milligram GAE per gram. From the studies of others previous research, both the extract has a higher concentration than BHA. The HBHA has the value of total phenolic content at 10.0103 milligram GAE per gram. For M.citrifolis extract, both solvents are able to show similar level value of that is 15.104 milligram GAE using ethanol solvent and 16.530 milligram GAE per gram for methanol solvent. Thus, this demonstrate that this plant sample have high concentration of phenolic by extraction using ethanol and methanol solvent. From other research, the extraction of phenolic are influenced by the solvent used for the extraction. By following order high to low, acetone, ethanol, methanol are the best solvent used for extraction method. In theory, methanol is able to extract more phenolic content than other solvents, but for this analysis shows that for red ginger, ethanol is better solvent than methanol. Meanwhile, methanol is better solvent than ethanol for M.citrifolis. The phenolic content and oxidant activity are correlate with each other because of the phenolic compound. It works as an antioxidant by interacting with different kind of free radical. Also transfer a hydrogen atom, a single electron sequential proton loss electron transfer, or distillation of transition of metal were the mechanism by which oxidant effect were carried out. The methanoic extract significant antioxidant content is what gives its bioactivity. Consequently, it's reasonable to predict that it will perform well in terms of oxidation of oxidant and antibacterial properties. For the next process, that is antimicrobial activity. The diameter of inhibition zone that were observed shown in the table below. From this analysis, it shows that gram-positive as epidermis, the zone of inhibition that found best is with M.citrifolis extract with methanol solvent at 0.106 cm, followed by N.citrifolis with ethanol solvent at 0.105 cm. A.purpurata with metal solvent at 0.059 centimeter and A.purpurata with ethanol solvent at 0.017 centimeter. For gram-negative, that is E. coli, the best zone of inhibition zone was found in M.citrifolis methanol solvent at 0.173 centimeter, followed by A.purpurata with methanol solvent at 0.127 and M.citrifolis with ethanol solvent at 0.11 centimeter and A.purpurata with ethanol solvent at 0.047 centimeter. Among two types of the solvent used to extract the plant sample, methanol is found the best. Overall, from this analysis, M.citrifolis with methanol solvent give the maximum effect on antimicrobial activity. The solvent used for the extracting the plant sample varies the result of the antimicrobial activity. Based on this study, methanol extract were better than ethanol extract. The quality of the component able to extract antimicrobial compound of the plant sample. Due to the quality of the solvent, they are different in the antimicrobial activity of the various solvents. So for the next analysis, there is gas chromatography analysis. Using National Institute of Standard and Technology in Nisabri, interpolation of mass spectra GCMS data was conducted. The molecular structure, molecular mass, estimated fragment, and probability were used for identification. The standardized Morinda Synopsis extract, GCMS chromatograph, as shown as figure below, reveals 11 main pits, which indicate existence of 11 phytochemical ingredients. The 11 phytochemical ingredients were described and identified within the mass spectrometer of the constituent were compared with niche library as shown in the figure. Also in the figure there are 13 peaks and 13 phytochemical ingredients for A.purpurata. Furthermore, there are 13 types of phytochemical ingredients were identified as shown in the figure below for A.purpurata. So from this analysis, there are many types of phytochemical ingredient present in the both extract. However, A.purpurata has more phytochemical ingredients than Morinda citrifolis. Most of the phytochemical present are in both extract what type of phenolic compound. This proves that both plant extract contain phenolic compound in their phytochemical constituent. From other studies, there was some deviation of the result of GCMS analysis. Some of the cause of deviation is because of the different extraction technique were used and different part of the plant were also used for this analysis. For the last part, there is the application of the plant extract on the homemade cake. At day 1 until day 9, all the type of cake show no growth of fungal on the surface of the cake, as shown in the figure below. Meanwhile, at day 10 to day 14, a number of fungal colonies able to grow on the surface of the blank M.citrifolis with ethanol solvent and M.citrifolis with methanol solvent cake. A large number of fungal and mold were able to grow on the surface of the cake with nothing added into it. A small number of mold will grow in the cake with M.citrifolis methanol solvent and M.citrifolis with ethanol solvent extracted and added into it. However, throughout the 14 days of the observation, no more fungal were able to grow on the surface of the cake with A.purpurata ethanol solvent and A.purpurata with methanol solvent added into it. From this observation, A.purpurata acid were able to prevent and preserve the cake from becoming spoiled and infested with mold. When the cake is stored in an environment with high relative humidity and high relative temperature, a cake moldiness can be developed. According to the species and the level of spirulation, the color of the cake can range from golden yellow to green gray. The mechanism of action of phenolic compound on the bacterial cell hypertrophy attribute to damage of the bacterial membrane, inhibition, virulation factors such as enzyme and toxin, and suspension of bacterial biofilm formation. Some unnatural polyphenol, aside from direct antibacteriality, exert a synergistic effect when combined with common chemotherapeutics. Furthermore, it shows that A.purpurata is the best plant extract that shows the performance as a natural food preservative by inhibiting the growth of the mold and fungi of the cakes. From conducting the study, there are also some improvement that can be done in the lab work of the study. One of the improvement that can be done is by using different concentration of plant extract on the antimicrobial test. Under that, optimize the solid extraction process with different parameters such as different running time and the extraction process. Also considering the use of other extraction methods like microwave assist extraction method or ultrasound assist extraction method. We can see there are a few impact from this by conducting this study. One of this is a better health from consuming a natural food preservative in the cakes. Other than that, more research on natural preservative can be done and increase the consciousness of safe food preparation practice. In conclusion, the plant extract were able to extract using Soxhlet extraction method. The plant extract were able to measure the phenolic content, antimicrobial activity, and identify phytochemical ingredients. The extract of A.purpurata shows that the best performance as natural preservative and methanol is a better solvent than ethanol. So that's all for me. Thank you.